Hi,
Okay.
and good morning. I'm Masyitah. Today I'm going to present my untitled investigation moisture content effect on bearing capacity failure of street footing rested on silty sand soil based on characteristic assessment using non-destructive tests. So I'm from Center for Civil Engineering Studies, UiTM, Pulau Pinang, Malaysia. This is on about how we can estimate or what we can determine the crack formations due to the soil bearing capacity failure. As what we know that the footing or foundations is a very important substructure below that carry loadings from the tops. So if you have a very weak soil, it can cause to the crack formation, for example. That's what I am saying here. So the structural stability mostly relies on soil foundation from carrying and transferring load to the layer or stratum of rock or soil. So the structural damage is significantly caused by differential settlement underneath the foundations, the structure, and triggering to crack formations on the structure. So furthermore, the presence of structural crack can be due to moisture content variation. As what we know, the environmental condition as well as the load and also the soil properties are the parameters control to the formations of the crack itself. So what is the bearing capacity? The bearing capacity of soil is ability of the soil to support loads without fail in shear, resulting to excessive deformation or settlement. So the effect of moisture content variation in dry and wet conditions for fully saturated, for example, degree of saturation is 100% or 0%, in unsaturated soil for degrees of saturation equal to 0 on the properties of the ground and the whole building, causing to soil deformation and differential settlement, which is mostly neglected in assessing the structural lifespan performance. So thus, in order to calculate the ultimate bearing capacity, incorporate the changes of moisture content and degree of saturations under the suction effect for unsaturated and saturated soil condition, as can be seen in these equations. So the equations originally from the Tzaghi assumptions for saturated soil. So it is adopted as well the Moore column failure envelope. So in order to calculate the bearing capacity for different moisture content on top of it has the saturated conditions and also unsaturated condition of soil. So this formula is more reliable and applicable in order to estimate the bearing capacity of the soil, which carrying the superstructure loadings. So this study aims to investigate effect of moisture content variations on bearing capacity of street footing on silted sand based on non-destructive test data informations. So the visual inspection was carried out and structural assessment of the buildings such as location, width of the crack, the length, and the pattern, and the condition of the crack were recorded in order to classify the severity of the cracks. A non-destructive test, for example, here we will conduct on the rebound hammer test to determine the compressive strength of the concrete for the affected crack area. So in order to have some information from the soil, so the geotechnical properties will also carry out on certain testing, for example, moisture content, the compaction characteristic, as well as the shear strength of the soil, according to the standards what we had in the lab. So in order to have some impact from the crack formations on the building itself. So the next one carry out on the numerical study for the bearing capacity failure of street foundation with a 2-meter width resting on the ground surface by using the geotechnical finding element software Praxis 3D. So all these informations from the non-destructive tests as well as the geotechnical tests were included in the numerical study. So the case area was selected in Penang, Malaysia, and you can see that this is the map for indicating the locations of the study area. So for the structural integrity by using the numerical study, so on the right side were tables for silty sands and also the footing. So you can see that the properties of soil and also the structures are important in order to have the analysis of the bearing failure. So in order to include the effect of the moisture content at this time, you can see that there are two values for unsaturated unit weight of the soil and also saturated unit weight of the soil. So below the ferrity level or below the groundwater table, so we're going to adopt unsaturated unit weight of the soil, and above we can adopt for unsaturated unit weight of the soil. So these are very important when you estimated the bearing capacity of the soil with different conditions of the temperature effect. For example, here we consider the moisture content during the dry and wet seasons. So from the result and from the result itself, through the visual crack assessment and as well as the rebound hammer test, for this point 1, it was considered as severe due to extremely huge crack width. So by refer to the Berlin scale, the approximate crack width of 15 to 25 millimeter was recorded, and it was considered as a severe damage. So this crack line was formed in a straight line about 3 meters upwards. So the pattern of crack shows that it cannot be considered as a non-structural damage. So on the right side is indicated tables that we have found on the crack assessment, for example, rebound number, and then the compressive strength of the concrete, the crack width, crack length, and also the crack damage category. So by conducting the geotechnical test, these are the tables, these are the parameters indicate in this table, mention that the soil type is a sand, silty sand, and the compositions of the soil itself for the sample, which has a percentage of sand, percentage of silt, and also clay, and the compaction characteristics indicate that the optimum moisture content is 17.05%, and also the maximum dry density is 1.83. So after we have this value of unconfined compressive strength, the stiffness of the soil can be estimated by using one equation established from the past study. So on part of the numerical study, for variations of the moisture content effect, by considering the degree of saturations at wet condition and also for the dry condition, as well as the degree of saturation from the 0.1% to the last 0.9%, as can be seen in this graph. And it shows that the higher degree of saturations and also the increase of the moisture content that will be increasing in the pore pressure resulted to the bearing capacity reduce. So these images indicates that the bearing capacity failure of the bear pressure below the footing itself, carrying 200 kilopascal loadings, indicating that the shallow footing has different bear shape patterns that indicate for different degree of saturation, 0%, 100% is a fully saturated, and the 50% for unsaturated conditions of the soil. So again, the effect of moisture content in the numerical study was assigned through the flow boundary conditions in this program or in this software. So a part of the conclusion that we have been made from this study is that the point 1 has experienced severe crack damage with crack width 25 millimeter, and the crack length is 3 meter. And this crack line was formed in the straight line about 3 meter upwards and considered non-structural damage. And from the geotechnical test, it is concluded that the sample is classified as silty sand, which we control the strength of the soil resulted to the bearing capacity failure. So the bearing capacity failure of soil from total displacement beneath the footing shows as moisture content and degree of saturation increase, the total displacement also increase. So this is due to the increase in the pore pressure and decrease in the shear strength of the soil. So that's end from me, and thank you for listening.